Good afternoon, class. Today we're going to be talking more about similarity. And before we continue, I want to make sure that you have a clear-cut understanding of the correct answers for page 460, numbers 31 and 32. We talked about in class today how tall the tree was with the eagle's nest in it, and we made the similar triangle using Sam's height and the length of his shadow. That is very similar to the question number 31 that says a 20-foot flagpole stands beside a building. The flagpole casts a shadow 25 feet long. At the same time, the building casts a shadow that is 60 feet long. How tall is the building? In order to answer that question correctly, you needed to set up a proportion where we have the ratio of the flagpole, which is 20 feet, compared to its shadow of 25 feet. And we wanted to know how tall the building was. We'll call it X. We don't know what it is. For a shadow that is 60 feet. We look for a relationship going across this way or up and down this way. And if we don't see something that multiplies by 20 to make 25 that easily, we can always make an equation by multiplying the numbers that are across from each other diagonally. So 25x equals 1,200. Divide by 25 to find the height of that building, and x equals 48 feet. So that is the answer to number 31. Number 32 is asking us to find the scale factor and then find the length and width of the quadrilateral JKLM, which is a rectangle. As you compare those sides, you will see that it has a scale factor of 1/5 or 0.2. Either of those answers would be acceptable when you compare them. So I would accept a scale factor of 1/5 or 2/10. Because it's getting smaller, whenever you have a scale factor less than 1, it produces something that is smaller. Then it said to find the length and width of JKLM. The length is 8 centimeters and the width is 2 centimeters. As we look more closely now for our pre-AP packet at similarity, the question is, do these two images show similarity? Some of you are going to jump and say, yes, that t-shirt looks like it was made by using the same scale factor every time. Without actually measuring, we don't know. But I thought that was kind of a crazy image. The same thing is true for the giraffes. We don't know if they're similar unless we match their corresponding parts, like the length of the leg to the length of the leg, tail, neck, and possibly their ears. But I don't know if it'd be real easy to measure the ears on a giraffe. But again, those are the things that we need to look at to see if similarity actually exists. I know that some of you will have the pink packet at your disposal right next to you. Some of you may not. That is okay. We will still discuss this and be successful with or without the pink packet. So for those of you who have your pink packet, please pause and make sure you have it with a pencil and a calculator ready to go. In a previous chapter, we talked about the similarity of two triangles using the side, side, side rule. And on the packet, it says determine if the following triangles are similar, and we need to explain how we know they are similar. So in this lesson, we are going to look at these right here, these two triangles, and determine whether or not they are similar. What you need to do to figure out if they're similar is look at the three sides and make sure they have the same ratio value. So, does 9 over 6, 9 compared to 6, that equals 1.5. Does the same thing happen when we take 18 divided by 12? The answer is yes. And when we take 12 and divide it by 8, we want to make sure that it happens for every corresponding part of the triangle, not just two of them, but all three, to prove that they have side-side-side similarity. Each ratio is 1.5, therefore the sides are proportional. These triangles are similar because the corresponding sides are proportional. So we look at that ratio value. Now they want us to take a look at number 1, and it says, is triangle 1 with side lengths of 8, 4, and 7 similar to triangle 20 with side lengths of 20, 17.5, and 10. What you do now is, since they're listed in order 8, 4, 7, that has to go with 20, 8 goes with 20, 4 goes with 17.5, and 7 goes with 10. So we figure out what those ratio values are. I'm going to quickly turn them into a fraction, just like this. And 8 divided by 20 is 4/10. I know that I'm not going to get 4/10 when I take 4 divided by 17.5. So these triangles are not similar. These are not similar. And again, to just confirm that, 7 divided by 10 is 7/10 or 0.7. So these two are not similar. We would test those. And then again, don't do extra work. Example number 2 for guided practice. Now we have these two triangles, 7, side length of 7, 10.5, and 12. And triangle number 2 has side lengths of 10, 15, and 20. So again, turn these into ratios, comparing these sides together. 7 divided by 10 is 7/10, so that's our value there. 10.5 divided by 15 is 7/10, but we always have to check all three of them, so it's looking good so far. 12 divided by 20 is not 7/10, it is 6/10. So again, 2 out of 3 does not make similar triangles. So again, these two triangles are not similar. I keep trying to think about what the magic word is, and I don't want to forget, but I think it's too early in the recording to give you the magic word. So let's go ahead and keep moving on. Flip to the next page, please, or if you don't have it, I have the diagram right here for you. We have this shape that's not a polygon because they intersect. We know that this angle here is given to us at 65 degrees. That's a big 65. And angle C is also 65 degrees. And as we look through this one, we know that angle A to E to B, A to E to B is 65. And we know that angle B to C to D is also 65. So we have one angle that is congruent. They have the same measure. We also know, I'm going to change colors here, we also know that these two angles right here are congruent because of a rule that we discussed earlier in the chapter, and it is called, you're trying to think of what it is, it's called, starts with a V, vertical angles. Those are called vertical angles. So now we have an angle and another angle. What do you know about A and D then? If you have two angles in a triangle that are the same, what's true about A and D? You're right. They also have to be congruent because of the rule that all of the angles in a triangle have to add up to 180. So if you know that two angles in a triangle are congruent, you can say that they are similar, because that third angle will also have to be similar. Something to look at. Always looking for parts that match. On this next one, we need to figure out if triangle MNO is similar to PQR. So MNO similar to PQR. Okay, so right here, this angle is supplementary to 150, so that is 30 degrees. So we have an angle that matches. Now we're going to check to see how our sides match. And we're going to say, is the ratio between 3 to 9, is 3 to 9 equal to 7 over 3 to 9, 7 to 21. And we're going to test that. You go ahead and see if you get the same ratio value for both of those. Now that you've tested those, you saw that they both became 0.33 repeating or 0.3 repeating, and they had the same proportional relationship with a shared angle. Therefore, these two triangles are congruent. Okay. There is a guided practice that I would like for you to do. So please take a moment to try to figure out if triangle GHJ is similar to triangle IKJ. So on page 381, if you determined for guided practice number 3 that those two triangles were not related, you are correct. They are not similar. The relationship between the sides cannot be the addition of the same number. It has to be either multiplicative or divided by multiplicative relationship, or have a relationship using division. The last example that we're going to look at is this pentagon. And we need to figure out the perimeter. So what we're going to do is figure out what the scale factor is for this one. We know that C and D, or line segment CD, goes with IH. We have to figure out the scale factor. So 4 times what, we'll call it X, equals 6. Well, it turns out, when you do that division, that X equals 1.5. Each of the sides of this larger pentagon is 1.5 times larger than the smaller one. So we'll go around and we'll fill this in. There's a 6. There's a 9, because that's 1.5, and then 5 times 1.5 is 7.5. And now we have all the sides of this pentagon using the scale factor. So we add all of them together, and we would get the total. And that total was 36. I'd like for you to try number 4, and we have 2 diagrams here. We have a quadrilateral that looks like this. That's 4. And we've got this quadrilateral here. They're supposed to be similar. And this is 5. And the perimeter of this one is 12. Now we're used to finding the ratio value using 2 sides, but you could also use it as one side compared to the perimeter. So pause, see what you come up with for an answer, and when you're ready, unpause to get the answer. And the correct answer is 15. The perimeter of the larger quadrilateral is 15. Tomorrow when we come to class, we will work on these together with your classmates. Didn't forget about that magic word. I'm going to go magic word is sunshine, because it's a lovely sunshiny day, and we're just going to go with that. So May there be